Hello guys, so today we'll be doing question 33 of LeetCode, which is search in a rotated sorted array. The question is, there is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, k, bracket 1, smaller than or equal to k, smaller than nums.length, such that the resulting array is nums k plus 1, nums n minus 1, nums 0, nums 1, nums k by the swap, okay, 0 index. So for example, an array of 0, 1, 2, 3, 4, 5, 6, 7 might be rotated at pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. Given the array nums after the possible rotation and an integer target, return the index of target if it is in nums, or minus 1 if it is not in nums. You must write an algorithm with O log n runtime complexity. Since that has to be in O log n, we know this has to be binary search. So anyway, let's look at the examples. Example 1. Input is nums 4, 5, 6, 7, 0, 1, 2. Target is 0, output is 4 because 0 is at index 4. Nums is equal to 4, 5, 6, 7, 0, 1, 2. Target is 3, output is minus 1 because it does not exist. Input nums is equal to 1, target is 0. Again, output is minus 1 because it does not exist. So the way we're going to do this is we're going to just create the start variable and the end variable. Well, the start is the index of 0, the end variable is the length of the array minus 1. And then we get the middle. We do this normal binary search, but we check if the second half of the array is sorted. If it is, we check through that array and proceed. I will check through the first part of the array. So let me show you what I mean. Let's use that example. 4, 5, 6, 7, 0, 1, 2. 4, 5, 6, 7, 0, 1, 2. Okay. So let's say the array is, as I said, 4, 5, 6, 7, 0, 1, 2. Okay. And the target was, I think, 0. 0 is the target. So the start is 0. Start is 0. End is 1, 2, 3, 4, 5, 6, 7, 6. So we get a middle variable again, and we do while we loop through the array while start is smaller than or equal to end. So let's get the mid variable here. Mid. So we're getting a mid variable. We get at the start and the end variable, and divide it by 2. So 0 plus 6 divided by 2 is 3. So the current variable is 3. 0, 1, 2, 3, 3. We get that 7. We check if that is the target. It's not. Then we check if the mid value is smaller than the end value. So mid is 3. If index of 3 is smaller than 2, then we know that this side is sorted, but it's not. Therefore, we know that this side is sorted. So let's go back to the here. Okay. So then we're looking through this side of the array, and we check if the target is 0. Okay. 0, 1, 2, 3, 4, 5, 6, 6. Alright, so yeah, we check if nums mid is bigger than nums end. We loop through here. Yep. Then we check if the target is smaller than this and bigger than this. If it is, we check if the target is smaller than the mid and bigger than the start. If it is, we know it's in here. If not, we know it's in here, the next part of the array. So this is because if it's bigger than this and smaller than this, since this is sorted, we know it will have to be in here. But since it's not, then we know it's in the other half of the array here. So we increment start to be the mid plus 1. So now start is 4. Then we do the same check. Now mid is 10, for 4 plus 6 divided by 2. So that will make it 5. Now let's get rid of this. 7. Okay, 6, 7. Now index of 5 is 0, 1, 2, 3, 4, 5 is 1 here. So again, we check if mid is smaller than end, which it is, so we know that this side is sorted. By the way, so from there we check if the target is bigger than the mid, which is 1, and smaller than end, or smaller than or equal to. If it's 0, we know it's not, so we check this side of the array. So, is target bigger than or equal to start and smaller than end? Yes. So we know that the array, that the number is between these two. So then because it's smaller than end, we set the end value as mid minus 1. So mid minus 1 is 4. Now 0, 1, 2, 3, 4, we check if the mid value, 4 plus 4 divided by 2 is 4 again. So we check if the mid value, which is 4, is equal to target, which it is. So we return 4. Let me show you how to do it in code. So we get the start variable, which is equal to 0. Get the end variable, which is equal to array.length minus 1. Then we loop through the array while start is smaller than or equal to end. Because as I showed on the whiteboard, if we did whilst target is smaller than end, then we will not find a variable because they are equal here, so the while would have broken. So then we check if nums mid, oh no, we have to get the mid variable, sorry. So let mid is equal to, we have to floor the variable, so it's not a decimal number. So if math.floor start plus end divided by 2, that's the mid value. Now if the mid is equal, no, if the numbers value at mid is equal to target, then we return mid, which is the index position of the current number. Else we check if the second half the array is sorted. So if numbers mid is smaller than numbers end, then we check if the target is in between this sorted array. So if it's bigger than, if numbers mid is bigger than, sorry, if target is bigger than numbers mid, so if target is bigger than numbers mid and smaller than numbers end, we know it's in between the second half of the array. So we set the start value as mid plus 1. Else we know it's in the first part of the array, set the end value as mid minus 1. Now if numbers mid is not smaller than numbers end, then we know the first half of the array is sorted. Therefore if target is bigger than or equal to nums start, and I just realized that we have to put target is bigger than or smaller than or equal to nums end as well. So if target is bigger than or equal to nums start and target is smaller than nums mid, then end is equal to mid minus 1, because we know it's in that half of the array. Else we know it's in the second half of the array, so we set the start value as mid plus 1. And then if it's not inside the array, we return minus 1. See if that runs. Yes, that should pass. Let's see. As you see, fast time complexity, this is of O log n. Just using a binary array, so we search in halves. We keep halving every time, so we don't loop through the whole O array at once. Thank you for watching.